In this section 310 part 1, we did one problem. Now we're going to do some more. And these are solving trigonometric equations. And really, it's not bad stuff. You just have to pay close attention to the directions. This one also says find all of the solutions. Because the trig functions are periodic, there are going to be infinitely many answers to every single one of the problems. Sometimes the directions box you in, and there aren't infinitely many, but this one will be infinitely many because it says find all. So we want to know, where does the sign equal -1? Now think about that for a second. Where does the sign equal -1? 3 pi over 2. Right? So x is 3 pi over 2. But actually there are other answers, because we could go all the way around and back down to here, or we could go backwards to get down to here. So how do we express that? Plus or minus 2 pi. 2 pi n, okay. I don't care what letter you use. N, okay, doesn't matter. And why is it 2 pi? Because on our tangent problems, it was pi. Remember that? Our asymptotes were pi over 2 plus or minus pi n. Why is this with 2 pi? Because the period of the sign is 2 pi, right? And when you are looking for multiple answers, they're going to be a period apart. And this is true. All right, one more. Tan x equals 1 over root 3. Now, when tan x equals 1 over root 3, you kind of have to use your, like, that means 1/2 over root 3 over 2. So where is that? What kind of angle? Pi over 6? Pi over 6? So tangent pi over 6. Okay, so be careful. Okay, no, it's okay. We don't even need to be careful. What are the rest of the answers? One of them's pi over 6. What are the rest of them? Pi n. And why are we doing pi? Because the period of the tangent is pi. Now, an alternative answer would be pi over 6 plus or minus 2 pi n. This angle is pi over 6. But wouldn't 7 pi over 6 also have a positive tangent value? So we could say 7 pi over 6 plus or minus 2 pi n. This is a long version of this. Would you agree? This is probably the best way to write it, but sometimes we think, as I go around my unit circle, there are actually 2 places where I get a positive 1 over a root 3.
Why are you able to do 2 pi in that?
Because this would take care of all of the 1/6. So this would be 1/6 and 13/6 and so on, 19, so on. This takes care of all of these. This puts it all together. Because if you take pi over 6 and add 1 pi, don't you get this one?
Yeah.
So they would duplicate. This is a long version. I'm not recommending that. I'm just saying that says the same thing as this. Back when we talked about coterminal angles, how do we find coterminal angles? Add or subtract a revolution. And what's a revolution? 2 pi. So if the answer to the question is everything coterminal with pi over 6 and 7 pi over 6, because these are the two answers in the unit circle, then the coterminals with those two would be written this way. But because the period of the tangent's only pi, if this were a sine or cosine problem, I'd have to do it this way. But because the period of the tangent's only pi, I can get away with writing just one little statement. Okay? All right, how about number 4? This is the best answer, so there's no confusion. That's the best answer. But that says the same thing. All right, what are you going to do with number 4?
5 by 6.
Yeah, you're going to divide by 6, and you have sine theta equals root 2 over 2. 6, or 3 over 6. Right? Now, where does that happen? Think about your unit circle. Where does it happen that the sign is positive 1 over root 2, or root 2 over 2? Where does that happen? At pi over 4. Where else? Take sine. Where's the sine positive? 3 pi over 4. Isn't that where our sine is positive? Because sine is what? So my answer is all of the angles that are coterminal with these two. So every angle that's coterminal with pi over 4, and every angle that's coterminal with 3 pi over 4. Is that okay with all? Pretty easy, not too bad. All right, let F and G in the xy plane, what are the x coordinates of the points of the intersection of the graphs of F and G for theta between 0 and 2 pi? Now that last part is helpful, because if we're between 0 and 2 pi and we don't have all that part, this would be the only answer. 0 to 2 pi is just once around the circle. So we're not going to have any of that on this answer. What are we going to have? We're not graphing it. What are we going to have? 3 plus 2 cosine equals 2. If we want their points of intersection, don't we want to know where they're equal? Yes. All right, so what do we do? Yeah, so I set them equal, so now I'm ready to solve this, so I will
Move the 3 over.
move the 3 over and then divide by 2. And then I'm going to think about my circle, and I need to know what angle has a cosine of negative 1/2. Where am I if I'm negative? Cosine. I'm here or here, right? I'm over here. And if the cosine is negative 1/2, what angle is that? 2 pi over 3. And what would be the third quadrant version of that? 4 pi over 3. And those are the only two answers to the question. Because we don't want all of them. We only want the ones between 0 and 2 pi. Okay? All right. Now we've got example 6. So we got to talk a little bit about the notation. if we want to square a trigonometric function, so if we want to talk about sine squared, does anybody see a problem if we just write sine x squared? Do you see a problem with that?
Are you squaring the x?
All right, am I squaring the x or am I squaring the sine? That's the question, right? So we could avoid the issue by putting parentheses. Now I know I'm squaring the sine, but it gets cumbersome with all these parentheses in there. So when we put a power on a trig function, we put the power after the sign. So this means the sine of x squared. And this would mean the tangent of x cubed. That's that we put the exponent there. If you put the exponent at the end, like Cole said, that would not be the sine squared, that would be the angle squared. So that would be the sine of pi over 6 squared, or whatever your angle is. Okay, so we're gonna put our powers right here. So problem number 6 says, find the zeros of this function. So that means, where does the function equal 0? Where does it cross the x-axis? All right, are you okay with this? Example 6. All right, so what are our steps here? We're going to solve this equation. We do first. Subtract 3. It may look hard because it's got signs in it, but it's a regular algebra equation. Just solve it. So then sine squared equals 3/4. And then what should I do? Square root. Like a regular equation. Caution, just like a regular equation, when you square root, plus or minus, and this one will be root 3 over 2. When you put the square root in, plus or minus. Now luckily, we're again between 0 and 2 pi. So we have to look at our circle, but we only have to look at the circle once around. Where does the sign equal positive or negative root 3 over 2? So let's think about just quadrant 1 for a moment. Which of our big angles has a y value, sine, y value of root 3 over 2? Isn't it this one right here? Which is pi over 3? Right? But because that's a plus or minus, doesn't that mean I need every pi over 3? Because these would be the positive ones and these would be the negative ones. So what are the answers to the question? Certainly pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Yep, that's it. Everybody follow all that? Why are we gonna miss that problem?
Plus or minus.
Or forget that, yeah. Remember, anytime you are rooting, you have got to put plus or minus in there. All right, let's look at the next one, see if we can make any progress with that. What are all the values once around the circle where cosine squared equals negative cosine? Remember, if they're telling us 0 to 2 pi, then we don't need the plus or minus 2 pi end sign. Okay, that's only if we're finding all of the solutions. All right, what do you want to do here?
Isn't that no solution?
solution.
So when you square something.
Okay, but can cosine be negative?
Yeah, but not when you square it.
Okay,
It's the
so
same-
that
same
side's gonna
thing.
be positive. But if cosine is negative, let's say your angle is right here, then the cosine would be negative 1/2. Right? But when I make it negative, then it becomes positive 1/2. This isn't negative. This is the opposite of the cosine. And if the cosine is already negative, then this is actually going to be positive. Right? Now, I don't know, there may be no solution, but I can't tell without solving it out. Okay, so what am I gonna do? Stop it, at least you had an idea. What am I gonna do? Sophia?
Do you like add it over and then take the cosine?
I think that is absolutely magnificent, yes. So we're gonna move the cosine over. And then she says, I can factor out a cosine. So if I pull out a cosine, what am I gonna be left with? Cosine plus 1? And then just like a regular algebra problem, what do I do after I have factored? Set them equal to 0. So cosine equals 0, or cosine equals -1. Right? Now, zeros and ones are special. Let's look at our circle. Where on the circle does the cosine equal 0?
You got a ladybug.
Oh, is it a ladybug?
It's a ladybug. I don't want to kill it.
Letter B.
I know. I was gonna try to get on my pencil and get out the window.
Oh, well, we got a screen.
Oh,
Show it to the iPad.
I just leave it in there.
Zach,
Show it to the iPad.
So where does the cosine equal 0? At pi over 2 and 3 pi over 2. Where does the cosine equal -1? Pi. So there are the answers to the question. You follow all that on? It's pretty easy, really. I mean, it's not too bad. All right, let's look at example A.
I think it's
What are the x coordinates of the points of intersection? All right, what are you gonna do for example A? What are we gonna do for example A? Set them equal to each other. So 2 sine squared equals root 3 sine. Okay,
Alright.
she'll be fine, or he'll be fine.
No, it's got a broken wing.
I don't know how you fix
No, I don't
that.
know.
All right, here we go. We set them equal to each other because that's what the instructions said. Said what are the points of intersection? All right. So what are you gonna do? Take a minute with your partner, see if you can figure out how to solve this, and we're just between 0 and 2 pi again.
Yeah.
Oh,
And so, you talking about math?
We kind of.
We were talking about what math is
We are, it was kind of, but like.
You got like additional things, so let's focus on this. All right, boys and girls, did you subtract, using Sophia's idea from the last problem, did you subtract the root 3 sign?
How did you just set them equal to?
Because it literally says, you're looking for the intersection between.
This board,
the intersection
what happens if you square root, square root?
Right here.
Well, it's the equivalent of 4, but you can do that. You can still do this. All right. What did you do after you subtracted? Factor out a sign. And you were left with 2 sign minus root 3?
The other ones.
Hopefully. And then you set them equal to 0, so sine equals 0, or sine equals root 3 over 2. Does that look all right? I gotta figure out where that happens. I never go anywhere without my unit circle. Where does the sine equal 0? And remember, your domain is this. So as you answer the question, keep that in mind. Where does the sine equal 0? At 0 and pi. Where does
Like
the
Kodak.
sine equal
so you're like Kodak.
root 3 over 2?
Oh. Kai's not.
Here or here, would you agree? And what are those angles? If the sine is root 3 over 2, pi over 3, and then the second quadrant, 2 pi. Yep, Avery?
Does it make you think like the question says what are the x coordinates of the point?
No. No, and these are, these are the x coordinates. You're solving for x. Yeah, yeah, you're solving for x.
Why can't we just divide it by sin it?
Okay, great question. Let's talk about that. So let's even go back to regular algebra. When you had a regular algebra equation, like x squared equals x, for example, did you ever do this? I hope not, because dividing both sides of an equation by something is fine, as long as the something isn't 0, right? And if you have a variable, do you know if it's 0 or not? No. So division by a variable is never allowed, unless somewhere in the problem you are absolutely sure that it's not 0. So, for example, often we'll divide by variables when we're solving for sides of a triangle, because the side of a triangle can't be 0. So we're using law of sines and stuff, we'll divide by 0. We'll divide by the variable, because the variable you know can't be 0. In this case, can a sign be 0? Yes, so we don't divide by it. Okay? Do not divide by a variable. Okay? Do not divide by a variable, because, okay? So, this is, and by the way, if you did do that, Olivia, it would be wrong, but if you did, you wouldn't get all these answers.
You only get
Yeah.
averages.
Yeah. So that's why you can't, you lose answers when you do it, you can't do it. All right, you good? Any more questions about this problem? All right, because now we're going to ramp it up. and we're going to solve trig inequalities, all right? Now, I want you to remember, back in Algebra 1, you solved equations and then you solved inequalities. And basically, there were only two little differences. One was, if you divided by a negative number, you had to remember to change the sign, right? And the other was, instead of getting an answer like x equals 4, you got an answer like x is less than 4, which is infinitely many answers. Remember shading on the number line? Yeah, so you got infinitely many answers. So the same thing's gonna be true. Procedurally, we're gonna do everything exactly the same, but then we gotta figure out basically where do I shade. All right, so let's look at the first problem, example 1. Oh, well, example 1, he's got drawn for you. So he's drawn it from negative 2 pi to 2 pi, so he's drawn 2 periods. And he wants to know, where is the sign, basically that's a sign function, where is it less than or equal to 0? Now when you have the picture, that's easy. Where does the sign equal 0? Doesn't it equal 0 at negative 2 pi, negative pi, 0, pi, and 2 pi? Isn't that where we actually equal 0? Look at your picture. Would you agree with that? Now, where is it less than 0? So think of, here's the 0 line right here. What part of the curve is less than or under the 0 line? Well, isn't it this part right here? Look, I'm shading just like I do with inequalities. And this part right here, that's where I'm less than 0 and negative. So what are the answers to the question? Everything from negative pi to 0, or everything from pi to 2 pi.
Matter if we use brackets or parentheses.
We gotta use brackets because in the problem it's a less than or equal to. So it's just like on the number line. The dots are gonna be closed, bracketed, or they're gonna be open parentheses. This one's bracketed. Yes, Avery?
Why wouldn't you add the negative 2 pi to it?
Oh, great question. I need to add negative 2 pi. I missed that entirely. Thank you. That's closed in dot, and it's included in the domain. Yep, thank you, Avery. Beautiful. Beautiful. So these are where it's equal, these dots. So that dot's out there all by himself, but he has to be included. Good work. Very good. All right, let's look at the next one, example 2. Now he hasn't drawn the curve for you. You are going to figure out 0 to 2 pi, so only 0 to 2 pi. You're going to figure out all the places where the sign is greater than or equal to root 2 over 2. All right, so let's just figure out where it equals at first. Where does sine theta equal root 2 over 2? Let's think about that. Where does that happen? Sine equals root 2 over 2. Happens at pi over 4 and 3 pi over 4. Are we good with that? Now, if we're going to do this 2 different ways, so you can figure out what works best for you. Here is my sine curve. Here is pi over 4 and 3 pi over 4. Does that make sense to you? So here are the 2 places. Are these closed dots again? Yep. Here are the 2 places where it equals root 2 over 2. So here is your equal line right here. Now we want to be above that? Greater than that? So won't this be our answer right here? So our answer is pi over 4 to 3 pi over 4. Now, he points out that if you like your unit circle, and I've kind of already got some of it graphed already, that you can do the same thing with the unit circle. Because here is where the y values are root 2 over 2. Where are they higher than root 2 over 2? Right there. So you can shade your sine curve, or you can actually do shading on your unit circle. That would be tough to do here, because this was 2 revolutions. You could do it, it had to be a little more involved. Here it's really easy. Everybody good with that answer? All right, number 3, here we go. We got an f function and a g function. What are all the values between 0 and 2 pi for which the f function is less than the g function? So in other words, we want 4 plus 2 cosine x to be less than 3. Does that make sense to you? All right. Well, what do you think we should do?
Subtract by 4.
What?
Subtract 4.
Yeah, let's solve the equation first, absolutely. So we'll go ahead and subtract the 4. Oh, getting ahead of myself. And then divide. So are you good with that? We want to know where the cosine is less than negative 1/2. Okay, now I'm going to do it both ways. This is probably the last time I do it both ways, but some people like to draw their cosine curve, and that's absolutely magnificent. I have to figure out where the cosine is negative 1/2. So here's my unit circle. Where is the cosine negative? Over here? Yeah. And where is the cosine negative 1/2? So negative 1/2 root 3 over 2. How big is that angle right there? 2 pi over 3. And then this one would be 4 pi over 3. So those are here. And here. That's where the cosine is negative 1/2, or here, these 2 places right here. That's where the cosine is negative 1/2. Those should be open dots this time. Eamon, see that? Those are open dots this time. And I want to be less than. So if I want to be less than, don't I want to be down here? So my answer is from 2 pi over 3 to 4 pi over 3. Now on the unit circle, I can do the same thing. But remember, we're talking about cosine. Cosine is x. So now I'm going to have a vertical line. Because I'm doing x's now. I'm looking at x's. This is where the x's are negative 1/2. I want to be less than that, so I want to be to the left of that line. And don't I get exactly the same shading? 2 pi over 3 to 4 pi over 3. Completely up to you. Just remember, if you're using the unit circle, for a sine problem, you're looking at y's. You want to be above or below. For a cosine problem, you're looking at x's. You want to be left or right. Are you ready for one more? One more, and then we'll call it quits here. Example 4. You and your partner spend some time with example 4.
Yeah, I was just seeing that. Sorry, I got that. Isn't that only when you look at it
Cool. I don't see your pencil working. Should be.
Are we on example
And
5?
Enzo, I'm not sure that's a good choice of seat
4.
for you. If that's where you want to sit, I'm okay with that.
I was just rotating because of the lack of count.
This is for he needed help. He just wanted my others.
I mean, you did have a perfect paper.
You wanted me on that.
3 minus root 3.
I see great networking with some groups, and I see some groups not networking at all.
This is team.
If you're the smart one in the group, help your friend.
That's why we were going.
You divide by 7.
Oh, you
Yeah.
like that's what I did. I didn't do that.
It should, yeah. Oh, you did that? I was gonna say, why didn't you say something?
The only reason I think it's not is because it's a cosine.
I was really around your car at work.
Oh, then you do it separately.
That just reminded me of one of the cold bag, you put the ball over, you get like the chills. Yeah. That's the best feeling ever. From the lot, that just reminded me of that.
Oh, you just let left.
I love keeping that room so cold. Huh? We'll get the blanket over. So good.
But 0 is it?
That's a lot simpler.
All right, did y'all solve it and get cosine has to be greater than root 3 over 2? So then you figured out, okay, where are the points? Where does a cosine equal root 3 over 2? And what did you come up with? What are your angles where it equals cosine equals root 3 over 2? What did you come up with? Pi over 6 and 11 pi over 6? Is everybody okay with that? So if I am graphing on my regular cosine curve, here's pi over 6, here's 11 pi over 6. and I wanna be greater than that, so I'm talking about this and this, would you agree with me? Or, if I'm looking at my unit circle, cosine x, I'm looking right here. I heard some great conversation from a group, and maybe you others were too, I only heard one. If you use your unit circle, you have to be careful how you write your answer, because it doesn't make any sense to say this. No, that makes no sense, because you have to have your little number first. Even if you turned it around, it doesn't make any sense, because doesn't that mean everything between pi over 6 and 11 pi over 6? And that would be all of this? So how are we gonna write our answer? Well, if you look at it like this, it's easy. But you can do it from here. How are you gonna have to do it, Gabby?
You have to make sure you start at 0.
Yeah.
So you're gonna do 0 to pi over 6, and then 11 pi over 6 to 2 pi.
Exactly. So remember, we are going around the unit circle in this direction. So we gotta start at 0. That's where we start. So 0 to pi over 6 works. Then we skip a whole bunch. And then we go from 11 pi over 6 back to 2 pi. Now, what are these brackets and things gonna look like? Is 0 included?
Yes.
Look at your directions. Is 0 included? Yes. Is pi over 6 included?
No.
No. Is 11 pi over 6 included? But is 2 pi included? So that would be your answer, that union that. All right, that's a little tricky in terms of writing the answer. We good? All right, my friends, that's it. Gather your things up.
Oh no, it's on the computer.
Literally.